Welcome to the deep dive. Today, we're going to get into something pretty specialized.
Really specialized. Yeah.
We're looking at a piece of professional broadcast hardware, specifically the Thor Broadcast F-2SDI-3G-TxRx-RM kit.
It sounds like a mouthful.
It does. But our mission today is to really unpack why a box like this is so essential, because it solves this huge problem of distance and, well, data.
Exactly. How do you move enormous uncompressed video signals over, miles without losing a single bit of quality?
And without running hundreds of heavy, expensive copper cables, this kit is basically the answer.
It really is. And what's so fascinating is just how efficient it is. It's a two-channel system, so you have a transmitter and receiver.
Right.
And it's built for these really high-demand serial digital signals all the way up to 3G-SDI.
Which, for anyone who doesn't know, is the standard for uncompressed HD video. We're talking data rates of around 3.0 gigabits per second per channel.
Yeah, a huge amount of data. And the key thing, the most critical insight, is that this kit moves all of that over a single fiber optic cable.
Just one.
Just one. And for the engineers on site, the immediate benefit is zero management. You literally plug in your video source, plug in the fiber, and it just works.
See, that's the part that sounds a little too easy. Fiber systems can be really complex. When you're pushing two massive data streams across one tiny strand of glass, what's the trade-off? Is there some kind of latency hit?
At the professional level, no, not really. The secret is all about how you use the light itself, and that's where a technology called CWDM comes in.
The CWDM.
Coarse wavelength division multiplexing. The easiest way to think about it is to imagine that single fiber is actually a multi-lane highway.
Okay.
Each lane uses a different, very precise color or wavelength of light. And because those wavelengths are far enough apart, they can carry their own data streams at the same time without interfering with each other.
So you're basically doubling the capacity of the fiber.
That's it. It uses specific light bands, like the 1310 and 1550 nanometer bands, to pull that off. And if you need even more, our sources show there are DWDM systems, dense wavelength division multiplexing.
More lanes on the highway.
Many more. You could potentially push, I think, up to 160 separate channels down a single fiber. It's just staggering.
That scalability is impressive, but let's get back to the practical side. For someone running a live event, what makes this thing reliable? It's a standard rack mount unit, standard connectors. But we're not just sending video, are we?
Oh, absolutely not. I mean, in broadcasting, video by itself is almost useless without its context.
Right.
This system is so critical because it passes all the embedded audio and, more importantly, all the ancillary data.
And that's the secret sauce, right? The things like time code, closed captions, all that metadata.
Exactly. Maintaining the integrity of that data is completely non-negotiable for any professional production.
And for the crew on the ground, I see it has, real-time status LEDs.
Yeah.
So you can troubleshoot instantly.
Which is key. You need that immediate feedback when, millions of dollars are riding on a live feed.
Of course.
And we have to mention the distance here. This is built on a standard 40-kilometer platform.
40 kilometers.
40 kilometers of uncompressed, perfect signal transport. That's the real-world impact. No degradation, no bulky copper cables.
So to bring it all home for you, this two-channel system we've been talking about is just the start. The technology easily scales up to 8 channels or more, all using that same core idea of multiplexing on fiber. So here's a final thought for you to mull over. Just consider for a moment the immense real-time bandwidth it takes to feed high-quality, uncompressed video to every single jumbotron, every broadcast truck, every control room in a giant sports stadium.
It's an incredible amount of data moving instantly.
It is, and it's specialized, efficient hardware like this that acts as the invisible engine making it all possible. It makes you wonder, what other critical pieces of infrastructure are you overlooking in your own world?